All right, so today we're going to be talking about fractures and how they form, where they're from, why they form, just pretty much what they are in general. So before we get into fractures and all the different types of fractures that there are, it's really important to talk about deformation. We need to get a sense of how rocks are moving and what they are in the bigger picture. So deformation, by definition, is an alteration of the size or shape of the rocks. It can be caused by stress, and these stresses on the rocks can stem from lots of sources. So they can be caused by temperature or moisture changes, shifts in the Earth's plates with tectonic movements, or sediment buildup, or even gravity. Plate movement is definitely the biggest factor of this. It causes great amounts of pressure that causes plate boundaries to change and changes as a result of deformation. So rocks tend to deform and produce these changes mostly in the position of the rocks. You'll see it in the way that they move, the shape of the rocks, and the volume, so things will get denser or less dense, or things like that. Ultimately, because of deformation, it produces geological structures like fractures and folds. So today, we're going to be talking about fractures specifically. So backtracking just a little bit, deformations, they can be broken down into three different types. So we've got elastic, ductile, and brittle. So elastic ones are types of deformations that change and then they go back to their original state. So they're kind of like plastic, you can fix it and then it goes right back. Ductile and brittle, these both cannot change. They can't go back to their original state. So these are irreversible. But today we're going to be talking about the brittle types of deformation, and those are fractures. So getting into fractures a little bit more, we can break these down into joints and faults. Joints and faults are the two main types of fractures that there are. Fractures are breaks in the rocks, put very simply. We can break them down, like I said, into joints and faults. We're going to separate the two on the basis of movement. So joints are going to be things that are just the break in the rock. No movement is going to happen, so you're going to have the two pieces of rock and there's just going to be the break right in between it. Faults, on the other hand, are going to be types of things that have movement to do with it. So the two rocks are going to move, and you're going to see that very evidently from like the naked eye, just looking at geological structures. You're going to see that movement, but joints you're not. So joints are just the break in the rock, and oftentimes plate tectonics and burial and erosion are lots of factors that can contribute to both joints and faults being created. So the joint is the one where no movement has occurred. So looking at the picture with the red arrow, you can see that there is that fracture in the rock. There's no apparent movement. The rock looks completely normal. All you can see is just that fracture down the middle. That's a perfect example of a joint. They usually occur in sets. That's kind of an isolated version, but if you look in the picture below it, you'll see that they happen mostly in joint sets. So they happen together, even though they can happen singularly, which is the picture right above. So moving on, joints can be broken down into a few different types of joints as well. So we've got columnar joints, and with this, these are going to be formed when the cooling of lava happens. So we can break these down into kind of the different materials that they're made out of. So basalt, you're going to find basalt in these types of columnar joints, and igneous rocks. So the picture at the very top is going to show columnar jointing. These are going to be, you're going to see columns. That's where the name comes from. But these are going to form due to the cooling of lava and the shrinking. So when lava forms and cooling happens, the surface area is going to shrink. And because the surface area is shrinking, the cooling causes those cracks that form the columns. So they create these perfect columns, and they're just long polygonal columns that, for the example that you see in the picture. A great example of this is Devil's Tower in Wyoming. So we'll take a look at that later on in the PowerPoint. But the next type of joint, another type of joint there is an exfoliation joint. These type of joints are generally curved, and you can obviously see that in the picture, but they tend to be parallel with the surface. Exfoliation joints are common in granite rock, so a great example of this is Twain Harte Lake. There's a granite dome that granite forms underneath the surface. That's where it crystallizes, and that's where it forms underneath the surface. But once it starts to expand and all the erosion of the top layers, once those go away, then nothing is pushing it down anymore underneath the surface. So the granite begins to expand once it is exposed to the surface. And once it begins to expand, then cracks start to form and it begins to exfoliate or breathe. So that's where those curved layers come from. So again, Twain Harte Lake, we'll look at that later in the slides. It's a great example of exfoliation joints. So the next type of joint that there is tectonic joints. These are super common, probably the most common types of joints that there are. They're formed when stress is super high. You'll mostly find these around, they happen like about the same time that faults do, but there's just no movement. So there's just going to be that plain split in the rock, just a crack in the rock, and no movement's going to happen. But it is caused when stress is very high. So moving on, those are most of the common types of joints that you will find, but now we're going to move into faults. Faults are another type of fracture. Faults are fractures in the rock where movement takes place. So different from joints where no movement's taking place. But basically there are going to be a few different types of faults. First off, we have dip-slip faults, strike faults, and oblique faults. These are all going to be separated by the types of movement that they have. So with dip-slip faults, those are going to deal with vertical movement. With strike-slip faults, those are going to deal with horizontal movement. And oblique faults are fun faults that deal with both vertical and horizontal movement. So before we get into the different types of faults that there are with dip-slip and strike faults, it's definitely important to understand a few things about how we describe these different types of faults. All right, so we're going to look at the hanging wall and footwall right now. So it's really important to be able to differentiate which one is the hanging wall and which one is the footwall. So whenever we're trying to determine what type of dip-slip fault it is. So the hanging wall and the footwall, looking at the diagram, you can see that the footwall is going to be the one below and the hanging wall is going to be the one above. Depending on if the footwall or hanging wall goes up or down is going to determine what type of fault it is, so what type of dip-slip fault it is with that vertical movement. This is only going to be important for the vertical movement. So, but looking back at the diagram, if you imagine yourself standing right at that line where the movement takes place, you're going to see the hanging wall is going to be above you all the time. Every single time the hanging wall is going to be above you. Whether or not the footwall is moving up or down, the hanging wall is always going to be the one that's above you. So always remember that, and then we'll remember that whenever we talk about which way the dip-slip fault moves, and then how to differentiate between that. All right, so going into dip-slip faults, these are going to deal with vertical movement. So first one we're going to talk about is the normal fault. With the normal fault, the hanging wall moves down in relation to the footwall. So you can see in the picture with the direction of each movement, normal faults happen when the crust is being pulled apart. So these are going to happen at divergent plate boundaries. So not convergent, but divergent plate margins is where these are going to happen. The crust is going to start to get thinner, and then these are going to be due to tensional stresses, but again, the hanging wall is going to move down in relation to the footwall is going to move up. So you can see that in the diagram right beside it. When this happens, it usually happens in a series. So it's going to happen in a pattern of ridges and valleys, and we call those horse and grabens. So those are going to be in the upper right-hand picture. You'll see that it forms a kind of ridge and valley feel to it, you know. The uplifted blocks are going to be the horse. The dropped down blocks are going to be the grabens. In most cases, or actually not in most cases, but in some cases, there will be half grabens. So this is where it's not a series necessarily, but it's where the structure is only bounded on one side rather than a series, so it'll be kind of a singular feature, but those are half grabens. But that's the normal dip slip fault, where the hanging wall is going to move down. On the other side of that, reverse fault is going to be when the hanging wall moves up. So relative to that footwall, the hanging wall is going to move up rather than down. These reverse faults are going to happen to compressional stresses rather than tensional, like the normal faults. So these are going to happen at convergent plate margins. You're going to see these when the rock is moving together. This is going to happen at subduction zones, mountain belts, and convergent plate margins especially. The crust is going to be getting thicker, and that's where you're going to see reverse faults. So kind of going off of those two, we have detachment faults and thrust faults. These are going to be exactly like the other two, just at a lower angle. So detachment faults are going to be normal faults at a lower angle. Thrust faults are going to be reverse faults at a lower angle. Most reverse faults are thrust faults. So these are going to be typically less than a 45-degree angle. So thrust faults are especially common in convergent plate margins. You'll see these in the Rocky Mountains in Alberta, Canada, and also around the Los Angeles area. So that's pretty simple about detachment faults and thrust faults. So moving into strike slip faults, we're going to talk about these in terms of horizontal movement. Strike slip faults are where the displacement moves horizontally rather than vertically. There are two types of strike slip faults, right lateral and left lateral. We determine this based on the orientation of the far side of the fault line. So this way the movement of direction is the same no matter which side you stand on. So for example, if you look in the diagram, the leftmost one, that's going to be your right lateral movement. So if I'm the red car and I'm looking at the blue car, I'm going to see the blue car moving to the right because that's the direction that bout of earth is moving to. So that's going to be your right lateral movement. Same thing if I'm standing in the blue car, or if I'm sitting in the blue car and I'm looking at the red car. That car in my orientation is moving to the right. So that's going to be your right lateral movement. So same thing with the left lateral movement part of the diagram. If I'm in that red car and I'm looking at the blue car, that blue car is moving towards the left. And same thing in reverse, the red car is moving to the left in the view of the blue car. So whatever you see and whatever direction that object is moving is going to be the type of lateral movement, the type of strike slip fault that it's going to be. So these types of faults produce shear stresses, and they're characteristic of transform plate boundaries. So it's where the plates are going to slip past one another. Great example of this is the San Andreas fault. So prime example. Eventually it's going to just go right on top of one another. All right, so in conclusion, we've learned that fractures are a type of deformation that can be broken down into two categories of joints and faults. Joints being fractures with no movement, and faults being fractures with movement. From there, we've got many types of joints: columnar joints, exfoliation joints, tectonic joints, all forming with different rocks and different processes. Moving on to faults, we know that these are classified based on movement, unlike joints that don't have any movement. Dip slip faults focus on vertical movement, strike slip faults focus on horizontal movement. In those, there are different types as well. We've got normal and reverse to detachment and thrust faults. We know that all of these fractures happen at various boundaries on Earth, whether it be at convergent, divergent, or transform boundaries. So we see all these fractures at these places, which is why mountain ranges are plentiful with these types of fractures, and they're great places to go, like the Rocky Mountains in Alberta, Canada, or any of those types of places. That's where we see lots of these fractures. So. That's the end of the lecture for fractures. I hope you guys learned a whole bunch, and yeah, thank you.